Okay, in this video, we're going to talk a little bit about using our calculators to be able to graph functions and to be able to help us in working with thinking about the graphs of f, f prime, and f double prime. All right, so let me pull my calculator back up so that we can see. And we have this first question says f is a function with a given derivative. How many relative extrema does f have on our interval? Well, one of the things we want to make sure that we do first is that we are in radian mode if we were working with calculus. Right? So our function is the sine of x squared plus 1. So I can set up the sine function of x squared plus 1. There is my function. And the window, it tells me a window for x values from 2 to 4. So I'm going to come to my window and I'm just going to look between 2 and 4 for my x values. Now, I know the sine function goes between -1 and +1. So I might, whoops, let me go here. I might say my y min to my y max is -3 to 3. So I'm going to graph. Okay. Now, this might be a little bit hard to see my graph, but we can kind of tell here, and we can say this is f prime. I crossed the x-axis once, twice, thrice, and 4 times. There are 4 times that f prime crosses the axis, so I'm going to have 4 relative extrema. Okay. Now, what about my next function? Here is my next function. Well, I can come over and adjust my graph, and I have this square root function, it looks like. So I'm going to clear. I'm going to set up to be able to make a fraction, and I've got the square root of x all divided by 1 plus x to the third power. All right? So there's my function. That's what I want to look at. And it says, what's the coordinate of the inflection point? What's the coordinate of the point of inflection? Well, the point of inflection is going to be based on the maximum for f prime. So I'm going to go ahead and say zoom 6 to get my standard window. And it might be hard to tell. It might be hard to tell where my function has a maximum or a minimum. And I can see that it seems to be only defined if x is greater than or equal to 0, which that makes sense. But clearly my window is too large. So I'm going to make my x min to be -1, x max is 10. That might be fine. And I'm going to just go from -1 to 1 on the y. All right, it seemed to be that my values were very small. And so there I see my graph, right? And my maximum of f prime is going to be the point of inflection, the x coordinate of the point of inflection for f. So let me go ahead and calculate the maximum, right, for my graph. And I'm going to arrow over so that I am to the left of the maximum. Right, notice that it says left bound, and that's clearly to the left of the maximum. Then I'll arrow over to the right of the maximum. Notice it says right bound, press enter. Now it says guess. I'm going to go ahead and guess, and my maximum happens to be at 0.473. So that is the x coordinate of my point of inflection, right? When my f prime is a max, 0.473, that is the x coordinate of the point of inflection. I look to my next problem. Here is f prime. Let me come back and pull my calculator back up. And y equals, let me adjust. Once again, if I'm working with trig, I want to make sure that I am in radian mode, and I am. So y equals, my f prime function is x squared times the cosine of x squared. So x squared times the cosine of x squared. There's my function. Zoom 6 to get my general graph. And oh my gosh, that looks really, really, really crazy for x squared. But notice that my interval is from -2 to 2. So I need to look close to -2 to 2. So I'm going to adjust my window. and the x min -2, the x max +2. Now draw my graph, right? And it might be a little bit difficult to see exactly what's going on between -2 and 2. So I'm going to adjust my window again, and my y min I might say is -3. My y max I might say is 2. Right, just tighten up that window a little bit so I can tell a little bit more. And notice that all of a sudden I can't quite see the bottom. I can't quite see the bottom of my graph, right? That if I look over, the lower part of my graph is not quite visible down here and down here. So let's adjust that window again and say the y minimum is -5. And now let's look at the graph. So now I can see that I have on f prime 1, 2, 3, 4, 5 relative extrema. And if f prime has a relative extrema, then f has a point of inflection. So 5 points of inflection on that open interval from -2 to 2. And then our last question here with number 19. All right, once again, let's look at our calculator. F prime, we'll go to y equals, clear this out. If we're working with trigonometry, make sure we're in radian mode, right? Y equals, and we have the sine function of x raised to the third power minus x. All right, so x raised to the third power minus x. And we are looking between 0 and 2. So let's adjust my window to be between 0 and 2. And my y minimum, -1, my y maximum, 1, because I know the limitations of my sine function, right? And in fact, maybe I say from -1.5 to +1.5, just to be sure I can see everything. Set up my graph. And on this interval, there I have what my graph looks like. So when is f increasing? F is increasing if f prime is positive. Well, what is f prime for us? F prime is this graph. So when is it positive? Well, it's positive from this value to that value. So I need to find these intersection points. Okay, well, let's check it out. I find an easy way to find an intersection is to set up a line of y equals 0. So now I draw the line y equals 0. This left point seems to be, let's see, what is the intersection between this line and that line? We'll guess to it, and we have an intersection of x equals 1. So on what intervals am I increasing? The answer is going to have to be, from my work, either A or B. Now let's find the other intersection. Second, calculate intersection with the x-axis. I'll arrow down to move to my first curve on the x-axis. That's close to the point of intersection. That's the curve I want to look at. Guess, and that intersection point is at 1.691 approximately to 3 decimal places. Right? For the AP Calculus course, you need to give your answers to 3 decimal places. If it's an IB Mathematics course, your answer needs to be to 3 significant figures. So we know from this work that our answer would be B, and once again, that is because that is where f prime is positive on our interval from 0 to 2. Okay? So let's go back and review those ideas. Once again, first derivative on what intervals is f increasing? That is going to be right if f prime is positive. So I'll go and try to find f prime positive. Right? How many points of inflection? Right? So if f prime is equal to a max or a min, then f has a point of inflection, right? And the reason for that is simple, that if f prime changes, right, if f prime changes from positive to negative or vice versa, then f has a max or a min, right? Well, if f double prime changes from positive to negative or vice versa, f prime has a max or a min. So a max or a min on f prime is going to be a point of inflection on f, right? Same idea applies right over here that we know f prime max or f prime min equals a point of inflection on f. And same idea that we talked about here on number 18. All right. And finally, if we look here, how many relative extrema does f have on our interval? Well, for this particular problem, if we're given f prime, if f prime changes from positive to negative or vice versa, right? If f prime changes from positive to negative or vice versa, then f has a relative extrema, right? Meaning that f has a max or a min. So those were the answers. We have a calculator that we need to start to learn how to use, but for the most part, we will still be at the point that we're providing you with graphs and wanting you to look at and work through the graphs on your own. As an example, with number 15 here, right? Table gives selected values of this velocity, and here's a particle moving on the x-axis. Which of the following could be the graph of the position of the particle, right? Well, we have a table. Well, let's look at our table, right? Here's a table. Well, what do we notice about the velocity? The velocity is negative, right? And if our function is continuous, right? If our velocity is continuous, then our position is continuous. So we go from negative to positive to 0 to negative, which means we need to be 0 somewhere over here, right? So we're going to have 0 somewhere between 0 and 1, but will also be equal to 0 at 3. So here is time, right? And there is velocity. We want to be careful with those items. So if we're looking at our graph, the velocity is 0, right? And the velocity changes sign. So that means that here is a minimum for position, right? And here is going to be a maximum for position. So I know I have a minimum followed by a maximum. So a minimum followed by a maximum. No, no, no. So either I'm going to have this graph or I'm going to have that graph, a minimum followed by a maximum. Then which of these two graphs is it going to be? Am I going to be a little bit more negative or a little bit less negative? Well, let's think about this. What do we know as well? Well, we know some points on our curve. We know that at 0, my function is at -1. That doesn't work, right? What about this function, right? Oh, no. What is this actually saying? Not my function is. This is actually saying my velocity is. So my velocity is negative. That kind of still could be, right? But then my velocity at 1 is positive, right? And notice that for this one, is the velocity at 1 positive? No, for this one, the velocity at 1 is 0. It's horizontal. So here I have the values that I need. C is the correct answer. These are logic puzzles. You want to be careful as you read them. You want to think about them carefully. Ask questions where you need. Thank you for your time.